Hi, so I'm Rizchel Dayao. I work at IBM, and today I'm going to be talking about Kubernetes and Docker, kind of just some of the pros and cons with it, if it's the right solution for you, or if there's another solution that's better, and then kind of just going through each of the different steps you can take to actually deploy your application. So a little bit about me. I graduated from Arizona State University with a degree in computer science. So there I did a lot more back-end work. Then I got a job at IBM as a front-end developer. So I switched to more front-end, more developing, not as much, deploying or anything like that. Now I'm a developer advocate at IBM. So now I focus on containers, Kubernetes, Docker, anything like that. So I've kind of made a big switch, and today I'm going to go over my journey of that switch, of going from a developer to learning more about containers and deployment and all that kind of stuff. And then just a fun fact. I'm a Denver newbie. I just moved here a couple months ago, so I'm still getting used to the cold and everything. And then just show of hands, who is familiar, has worked with Docker and Kubernetes? Okay, so a lot of people. Okay, so as most of you know, if you've been in technology or software, this is a typical development lifecycle we have. We go from planning, then we go to design, develop, testing, deployment, and then maintenance. So as a developer, I was pretty good at mostly all of it except for the deployment phase. So at IBM, we had a DevOps team that basically we pushed all our code up, and some magic happened, and all our stuff was in production. So for most of the other parts, like planning, design, especially development, I felt a little bit like this. I was like, I've got this. This is, where I can shine. I know how to code. I love it. It's great. And then for the deployment part, this is more how I felt, which is probably not the best, and I'm sure a lot of you have seen this as well, going from between the developer handoff to the ops handoff. So I was kind of like, hey, worked in dev, doesn't work now. It's kind of your problem. It's probably not the best way to think about it, but that's kind of how I thought about it. But then I switched teams. So I kind of had to change and learn about containers and deployment. And I also wanted to learn about the deployment process. Not that that was my new job, but I think it's important for everyone to know, especially for personal projects and everything like that. It's good to know how to deploy things and get it out to your users. So for me, I was like, I'm starting on this big adventure. I was very intimidated with all kind of DevOps stuff. I heard a lot of not horror stories, but people were just kind of like, hey, it's a little scary. So for me, I was really like, okay, this is going to be a big adventure for me, so let's see what happens. And then I started researching all the different ways to deploy an app. And ultimately, I was overwhelmed. There's a lot of different choices out there, especially starting off. You don't really know what to choose, why to choose it. A lot of my peers were like, hey, Kubernetes is great, just use it. But other than that, I didn't really have much more background about it. So it's kind of like this. What do I use? So, there's static generators, which is what I had a lot of experience with my personal website and whatnot. And they're really easy, so you could do it on GitHub or Netlify or anything like that. So it makes it really straightforward. And then also virtual machines. So that's a big one. Cloud Foundry. A lot of my applications I hosted on there too. It was just easy. You need a manifest file, and you kind of got it up there. But then containers. So containers I'd always heard about, in my job every day. I think it's kind of a big buzzword. So ultimately, I decided to go with Kubernetes. So this was because I could learn about containers, but also learn about something, that's coming out. And at IBM Cloud, we specifically deploy all our stuff on Kubernetes. So not only for me, I wanted to learn for me, but kind of how everything works, especially at a production level. So some of the reasons why I chose Kubernetes. So learn about containers and Docker. Kubernetes, you have to have containers to deploy it. So I just want to learn more about that. Community support and documentation. So because the Docker community and the Kubernetes community is so big, there's a lot of documentation on it, which when you're starting out with some new technology, it's really good to have documentation, or you can end up spending days just trying to debug it. And then automation. So with Kubernetes, it does automate a lot of stuff. So this might be my developer perspective coming out. But a lot of the stuff I could automate and not have to really deal with. And then scalability. So a lot of applications, you need to be able to scale depending on how much traffic you're getting and users. And Kubernetes, I read a lot that it scales automatically, and it would kind of take care of that for me. So what is Kubernetes? So Kubernetes is open source, and basically what it does, it can automate your deployments and do the scaling as well as the management of your deployments. And I'll kind of go more into this as my talk goes further. But first, let's look at containers. So I'm going to go kind of into the foundation of what you need to know before you deploy in Kubernetes. So containers are made up of container images. So you can have multiple images in one container. And then the images are made up of basically all the configurations and dependencies that the particular application that you're containerizing needs. So anything like in your package.json, anything like that. And then it is on an operating system level virtualization. So if any of you are familiar with like virtual machines, you have like a guest operating system as well as the host. Where on containers, you just have a host kernel level operating system. So all your containers on there can share resources. And then, like I said before, multiple containers can run on top of this OS kernel directly. And they're all basically isolated containers. They just run on top of the same operating system. So this is a graph or a picture that you can see on the left-hand side, it's virtual machines. On the right-hand side, it's containers. So with virtual machines, you can see how each one of the containers needs to have like its own guest operating system, which adds a lot of load. And if you don't need it, why would you use it? And then on the right side, you see containers where it just has all its configurations, everything that's needed for that particular container and image, and then it all runs on that host operating system. So some of the benefits for this, it's lightweight. So it's more lightweight than that virtual machine because not each one of your virtual machines needs an additional operating system. You only have to share one. It's platform independent. So because everything in your containers has anything it already needs, dependencies, anything like that, you can basically run it on any platform. Isolation and resource sharing. So kind of in that picture you saw, it's all isolated. So anything in a particular container has anything it needs, and it's isolated from all the other containers, but it does share resources at that host operating system level. And then it's ideal for a microservice architecture. So microservices, a lot of people are using them. That's how they're architecting rather than a monolithic service. So this is great because for each one of your microservices, you can make that into a container and then deploy it that way. So how do we package our application into a container? And this is where Docker comes into play. And basically what Docker does is it takes the application you have, it packages it and gets it ready to basically deploy it on Kubernetes or wherever you're going to deploy it to. So there's also other options other than Kubernetes, like you could use Docker Swarm and whatnot. And then there's also other tools that you can use instead of Docker to containerize your application. So I'm going to show you specifically how to containerize a React application. So it just has a front end. It's not super complicated. I just wanted to learn how to do it. And there's definitely many more things you can, but I'm just going to show you how to do it with a React application. So if you want to kind of follow along, all of these instructions are in this repo and the application. So if you guys want to deploy it, go for it. And so the foundation is on Node.js. So this is going to be important for the Docker file where we have to put in some of our configurations and our base image and whatnot. And it uses this API, so just a little bit more information about this repo, but it uses an API that it displays to the user with the data. And then it's one application. So for some containers, if you have multiple microservices, you might have a front end, a back end, a database, everything like that. But this one's really, really simple. It just has one application for it. So this is the architecture flow of it. So as you can see, the user comes to the web page. They send this API request. They get back a JSON object, and then it goes back to the user. So you can see within the cloud, that element, you can see that it has container wrapped around it, and then it's deployed onto Kubernetes. So first, create a Docker file. This is the first step you're going to do anytime you're dealing with Docker or any containers. And then a Docker file, basically, it's used by Docker to build an image. So like I've said before, it has all the configurations, anything that Docker needs to know how to build your image and run it. And then it has a document that contains all the commands. And some of the examples are like based image, what port you're going to expose it to, anything like that. So this is just a screenshot, sorry if it's a little small, of what a Docker file could look like. So at the top, you can see the base image. Like I said, it's built on Node. And then you're going to give it a working directory. So this is where all of your application files and whatnot are going to be in. And then you're going to do the npm install for any dependencies and whatnot. And then one thing I'd like to kind of point out is what port you expose. So when I first did this, I did a different Docker port and a different Kubernetes port. And I spent about a day trying to figure out why it wasn't working. And it was all because of the ports. So I learned my lesson there. And just make sure that your ports are always the same. And then on the bottom, you see it's just how you start the application. So Docker can start the application with npm run start. So to build the Docker image, so this is the commands you would use. So a prerequisite for this is, of course, having a Docker account. So make sure you have a Docker account. Export that Docker username, and then you build it. So Docker build is the command to build your image within Docker. -t is just what you want to name it. So for me, I just did my Docker username and app image. You could also do it a couple different ways. So this is going to be built in the directory that the Docker file exists. If you're not in that directory, what you can do is you can say what file that it needs to go to build that. And then it just kind of shows that's what it'll look like at the end after you successfully tagged it. As far as tagging, you could also tag like version 1, version 2. This one, I didn't tag it, so it's just latest, which some people can kind of a little bit confusing because sometimes the image that's marked latest isn't the latest. So it might be good to do version 1, version 2, anything like that. And then next you run the image. So Docker run -p, 3000 is the port, and then basically the Docker image. So what this is basically doing is this is just, putting this into a container and then running it on that container locally. And then it gives you your container ID. And then you'll access it locally. So this one would be like localhost 3000. You'll be able to see it there. Depending on what port you put, that's how you would do it. So now let's deploy our containerized application. So now we've built a Docker image. It's all ready. So I'm going to be showing you specifically how to do it with IBM Cloud. And our services, of course, there's like AWS, Google, all of those, but I'll specifically be showing you with IBM Cloud. So, and then these are just some Kubernetes definitions before I get into it that are good to know. So cluster is kind of the biggest element within Kubernetes. So you basically create a cluster, and it has all of these different nodes on it, or worker machines, and that's where your containers are going to run on. So a node, basically, is just something that runs the application. So this could be like, this is a physical machine. It could be like a virtual machine, but it's still some sort of server. And that's how your applications will run. And then within that node are pods. And these are abstractions of those containers. So rather than having to manage a container, you're going to manage a pod. And these just have the groups of your containers or a single container. So this is just like an architecture diagram. You have your master, so that's your master cluster. That's what's going to kind of take care of a lot of the automation stuff you have to do, or any of the scheduling, anything like that. And then each of the nodes has a proxy and just ways to manage its own node itself. And then the pods just have all the containers. So some prerequisites you need specifically to run it on IBM Cloud. So you need an IBM Cloud account, of course. You need to install the IBM Cloud CLI. You need to install the IBM Cloud Container Registry CLI. So the Cloud Container Registry is IBM's version, I guess, of Docker. It's where you would host all your images, and that's where you're going to get it rather than from Docker. I know a lot of the cloud platforms do have their own version of it. And then you need to install the Kubernetes command line. So everything I'm going to show you is going to be through the command line. So first you can create your Kubernetes cluster. So this is in IBM Cloud. And these are the specific steps that you take, because it can be a little confusing. There's a lot of services. So just look for the Kubernetes. And then for this one specifically, you only get one node, but it's free. So this one isn't that big of an application. So you can run it with one node. But if you need more, of course, you can. But if you just want to try it out, the free version gives you one node. And then you create it, and this is what your dashboard looks like. So you can see like your cluster ID, how all your nodes are doing, anything like that. So, and then before you do anything with Kubernetes, you need to get the cluster config of your cluster so you know where to push up any of your images and how to run and deploy them. So it'll just be this command, and then you'll get something back kind of like with an export kube config. Just make sure you export that in the command line, and then it'll be pointing there. But just one thing to know, every time that you do something with Kubernetes, you do need to export it or somehow have that, maybe in your bash RC or anything like that. But you do need to save it, or it won't know what cluster to work with. So next, create a namespace. So this one's pretty straightforward. This one just might be IBM specific. I'm not sure, I haven't checked the other ones. But this basically just says where all your images are going to be. So like my namespace was just Dayao, it's my name. But it could basically be anything, but that's where all your images are going to lie. And then build that image in the IBM container registry. So this is basically the exact step we did earlier with Docker, but we just have to build it in IBM container registry because we can't pull in those Docker images with IBM Cloud. But it's basically the same command, just a little bit different. And then the registry, so it's bxcr build, the name. So depending on what region you're in or what namespace, you're going to change those, everything in pink, depending on what. And then the name of it, so deploy React Kubernetes, you're going to change that to whatever you want to name it. And this is the exact step that we did in Docker, so it's going to be the same. And then next, so run the container on the cluster. So you're going to run a deployment. It's called a deployment. You're going to run it, and then you're going to say what image to do. So kubectl, which is the Kubernetes command line. You're going to do kubectl run app deployment, and then whatever image you want to do. So that's why earlier you had to create that image and build it on the container registry. And then your deployment's going to be created. And then once you have your deployment, you have to create a service to expose the deployment. So it's now on Kubernetes, but now you have to expose it to the outside world to say, hey, this is how you can access this specific cluster. And then you just expose it, so you're going to do deployment, and then whatever you called your deployment, it's going to be slash whatever you called your deployment, and then type is node port. So you guys can use node port or load balancer. For more advanced, you probably want to use load balancer. For a first time though, node port kind of does its job. Load balancer just it does a better way of managing the traffic and where it all goes. And then you say what port it goes to. So at this point, your application should be running on that cluster, and you should be able to access it. And probably many of you are wondering why I haven't shown any YAML files or anything, because with Kubernetes, you always have to use YAML files. But for me, I didn't want to deal with any YAML files, so I kind of seeked out a way to not to. But if you guys want to check it out, in the repo, there is a YAML file that you can use. And YAML files basically just give you more configuration and control over your Kubernetes cluster. And then you just access it. You get the public IP address of the cluster, and then the node port, and then you can access it like this. So at this point, you have everything up and running in Kubernetes, everything's all good, and then you can just access it. So this is the repo that I pushed up, and it's really simple. So some advantages. Now I'll talk about some advantages and disadvantages of Kubernetes. So automation, it can do a lot of automating for you. So it automatically scales. So depending on how much traffic you're getting, it will add pods, which is really nice, so you don't really have to worry about it. Self-healing, I've witnessed this firsthand. If any of your pods go down, or if any of the health checks don't pass, it will automatically bring that pod back up and get it up and running. So I've had that happen, I think, a couple times. So it was nice to know that, you know, if it does go down, then you can get it automatically back up. And then you can have rollouts and rollbacks. So this is a good way if you have multiple versions of your application. For the rollouts, it basically makes sure that you do not have any downtime on your containers. So if you have a really big production application, you don't want your application to go offline and then come back. So this makes sure that it rolls it out while your application, your cluster is still live, and then it'll roll out the next pod. And then also scheduling. So if you want to schedule anything, any deployments or whatnot, you can automatically do that as well, and it'll take care of all of that. And then load balancing. So I touched on this before. You could use a load balancer instead, and what a load balancer does is it'll give like an external IP address, and it'll just direct all your traffic to that. And depending how much traffic you get, it'll do a little bit of management on that part. And then modularity. So this kind of goes with the containers, you know, idea that each container or each pod has a different microservice, so it makes it very modular. So if one microservice goes down or one pod goes down, it's not going to affect everything, which can be really nice because you don't want your whole application that's in production to go down if one small thing does. And then it's open source. So it's great that it's open source, and you can kind of check out the code and see all of that. Anything open source is good. So some of the drawbacks. So it does have kind of a steep learning curve when you're first getting started with it. The good thing is there is a lot of documentation. But it is kind of hard to wrap your head around how it all works and how to get started. And then it does have unnecessary overhead if you have small, simple apps. So if you have like a really big production app, it's going to be good with multiple microservices. If you're doing it for like a side project or maybe like your own personal website and not a lot of people go to it, like that's adding a lot just for, you know, what you need it for. So I would suggest for that, you know, you can use like Cloud Foundry or something like that, something a lot smaller. And then the setup. So the setup with Docker was really great. It was really easy. Like I did it not that long, but with Kubernetes, it did take a while to set up. Just getting the cluster up, that took a while, so I had to wait for that. And then just kind of getting all the different commands you need and everything like that. And then some common pitfalls when people first start working with Kubernetes and containers. So the configuration and setup. So this specifically, I'm talking about the YAML file, which I didn't show. Everything in the command line that I showed would be shown in the YAML file. But the YAML file, like you have a YAML file for deployments, for services, for all these different things that you can get out there. So that can just kind of be confusing on how it all works and how to set that up at first. And then misusing containers. So I think the good rule of thumb is to just have like one microservice per container. But some people try and like just get everything out in one container, and that's just too much. It's going to be an overload, and it's not really how you're supposed to use containers. And then moving from beginner to advanced. So I think getting Kubernetes up isn't that bad, but I haven't really messed with a lot of like the advanced features later on. I've messed around a little bit with Istio, but that's kind of a whole nother beast. But I think kind of going from getting something up there and deployed to actually managing is kind of a big jump. And then next steps. So this is next steps just after this talk, and what you can kind of do with Kubernetes. So continuous integration and deployment. So I personally want to get this in like my Travis continuous integration tool, just so I don't have to go in and redeploy it every time I have a new version. If I have it in Travis, I can run all my tests and then get it deployed all in one, which makes it a lot easier. Multiple containers. So this would kind of be like multiple microservices. So if you add a backend microservice, a database, anything like that, you could see how all the different containers will work together and communicate. And then testing with advanced features. So this is just more of like testing out the scalability to see how it scales. I've seen the self-healing, but just kind of testing it out to see how the Kubernetes clusters work when it has to do some of those things that it says it does. And then Istio. So Istio is a new tool that works really well with Kubernetes, specifically for if you want to test like how well your application will do with traffic or A/B testing. It just adds a couple more advanced features. It also adds security between all your different containers. So if you want to like encrypt or have encryption keys between your microservices, anything like that. So Istio would be a good one to kind of work with to find more advanced features. So I just want to say thank you. You guys can follow me on Twitter if you guys have any questions. And then these slides are available online as well. There's the link if you guys want to follow it. And then that's about it. Any questions?
Yeah, so in your Docker file, you had a dependency on a base image, right?
Yes.
And
yes.
When you built that using Docker, it pulled that from the Docker image repository.
Yes.
And you said when you switched to IBM that the IBM Cloud does not have access to the Docker image repository. So how is that base image able to be resolved?
So I'm not 100% sure. I could double check, but I would think that the IBM Cloud Container Registry has a lot of the base images that it would need to use, because it's supposed to basically replicate Docker's functionality just for the IBM Cloud Kubernetes. So I would imagine that it would have those base images within the IBM Cloud Registry that you could pull from. Does that make sense?
Yeah, so they happen to have ones of the same name that presumably
Yes.
have the same functionality.
Yes.
Okay, thank you.
Yeah.
Thank you.
Any other questions? Okay.
All right. Well, everyone, put your hands together for Rizchel. Thank you so much.